So, as mentioned before, we have a range of bytecode that will trigger that particular action. So when the user places that particular bytecode, it will load pretty much. It will activate a field, like a data field, an input field of a form, where user can then input some sort of string. That string will then call a particular data field from their API. The user places the object, and it will call for that particular query, and the user will then attach that particular query to the object. So in this sense, the user is facilitated with a complex interaction. If we remember to the previous slide of the hidden complexity that we have behind the object, that is what the actual bytecode is doing. It's enabling the user to perform a very complex transaction with the computer or through the computer, and just downloading all that information to the single object. So this way, when the user combines different bytecodes together, they're able to combine and create a very complex transaction. So the interface allows the user to combine a wide range of data fields, a wide range of booleans, and also perform some navigational tasks. So by allowing the user to offload the data or offload their mental tasks to the object, users are able to combine and produce more complex relationships. So combining creators, combining places, combining logic, everything within a single query. But anytime that the user wants to change any kind of the transaction or any part of the transaction, then they're able to go back and fix and tweak that particular section of the query. So this eases the process of query making processes. Okay, so one of the main challenges that we have is that we are using semantic web technologies to explore the collections within Europeana. So this means that all information is linked and needs to be queried in a particular way. So to begin understanding roughly how this information is organized, we start with the semantic web layer cake. So we originate this from the idea that every single object on the web, or using the semantic web, or at least through Europeana's collections, has a URI. This is a unique resource identifier. This means that every object will have a particular address where that object can be identified. That way, in this example in particular, this is a person and his name is Fred. So that way we can know that there's perhaps hundreds of Freds in the world, but this is the unique Fred that we're going to be talking about. So in order for us to describe to the computer, because this needs to be machine readable as well as human readable, that means that humans as well as the computer, they need to understand the information that we're describing. So in order for us to communicate this information, we have to use a particular syntax. For this we use XML. So this way you first tell the person, you first tell the computer that you're talking about a person, you're describing a person. So we can describe a person that has the name Fred and his age, and perhaps another person which name is Anne and his age, and so on. So we can carry on describing these different type of names and age of people. And then you can also describe people that you like, people that you hate. So you describe different characteristics of through the code using XML to describe those particular relationships. So once we describe what is a person, and that person's gonna have a name, we can also combine that metadata or those descriptors in a more complex syntax. So for this we use RDF or RDFS, which is the Resource Description Framework. This way what we do, we create triples of data. We have a subject, a predicate, and an object. So this way we say, okay, there's gonna be a person, and that person is gonna have a name, and that name is gonna be Fred. This way, we create a rule where we create a schema, perhaps the way we describe that every single person will have a name, and that by default, every person will be then linked by name. When we say a name, we know that that name is related to a person. So those assumptions are made by the computer as well. So there are particular taxonomies, or there are particular ontologies which are used to describe these sort of relationships, such as friend of a friend or FOV. So FOV has particular has the RDFS ontology, so the data model already embedded in order for us to use and describe these different relationships. So in the case of Europeana combines a different range of ontologies. So this way they're able to describe these different relationships of people, of collections, of organizations. So they use friend of a friend to describe perhaps relationship of authors. So that way when you have a describer of a creator, you can also describe relationships of that particular author with other authors, so influencers, or perhaps assistants, or perhaps parents, brothers, sisters, wives, and so on. So we can also describe different type of relationships. So these ontologies, or these data models, are described through the namespaces in the XML, or in this case of the RDF XML. That way we can always call a particular element of the data model. So these data model and ontologies, which specialize in different type of connections, will help us to describe and provide that particular logic of the object, or the collection, or the actual knowledge that we're trying to describe. So in the case of Europeana, we have to be very clear of what do we mean when we say person, or when we say object, or when we say organization. So common misconception could be when we ask if Spider-Man is a person. So many people might jump and say, yeah, Spider-Man is a person, but if we think about it, the way it's actually described, Spider-Man is not actually a person, because a person is actually within the data model, a person is actually a physical thing. Meanwhile, a character such as Spider-Man is a man-made thing, is a concept, is not actually something that we can actually touch. A very easy way to actually understand this, if someone from outer space comes in and we're trying to describe what this is, we probably wouldn't say that you can actually meet Spider-Man, the real Spider-Man, as a person. It's actually something that has been created. So when we actually implement this type of logic within the computer, we actually have to take the same approach. The same way we're describing real things, that the same way that the ontologies are being used to describe that particular object. And this triggers one of the main challenges of the semantic web, or for what I see as one of the main challenges of the semantic web. In order for us to explore the information, we have to use Sparkle. So Sparkle is a query language where we have to describe what is it that we want, such as we need to tell, okay, we're looking for a particular title of a collection, and so we have to describe what the title is in order for us to retrieve something. So using Sparkle might seem as a very complex task, especially for people who don't have a huge background in programming, or perhaps in querying languages. So we can always try to facilitate this. Okay, so in order for us to perform Sparkle queries, we need to do it through an endpoint that enables the access to the actual collections, to the actual repository of data. So this is the British Museum Sparkle endpoint, where we can actually put some Sparkle queries. So this is actually looking for the object. This is the ID of the object, and this is the actual URL of the object, the URI of the object, sorry. So by executing, we actually retrieve the data, the predicate, and the object. So we have a triple of data. So we can actually see that the British Museum is the one who holds the particular object, has a representation. It has different sets of data we can actually retrieve from that particular object. Okay, so in the same way that the British Museum enables us to access their data through their Sparkle endpoint, Europeana also allows us to do the same thing. So this is quite challenging, because first of all, we have to actually describe the ontologies or the data models that we're going to use. such as the European data model, the Open Archives, Dublin Core, and each one describes the data in a very particular way. Then we have to also describe exactly what is it that we're looking for. So we have a range of objects that we want to retrieve. So we want to have the title, the URL, the creator, and the source, where is it coming from. So then I assign that the resource that we're looking for are actually within the Europeana data model, they're described as sound objects. So Europeana has a description of the type of the file format of the object that we're actually trying to retrieve. So they have image type picture, or type sound, or text. So this way we can also search by type of object. We can assign the DC title, which is the actual given title of the object, to the title field. We're gonna be using DC creator to find the creator, and DC source, which is the URL of where is it coming from. I'm gonna also find where is the media URL to find the object. We're gonna display this as a series of tables in HTML. We have different formats of how we can actually output this data. So as HTML, we can start looking at that every single field that we got is now populated by the data. So we have the different titles, and we have the particular location of the URI of that individual object. We can also retrieve this data as JSON, as a JavaScript notated object, and that way we can also navigate the information in that particular way. So this way we can use JavaScript to visualize as well that content. So as we can see, retrieving data in this way might seem as a very powerful tool, and it is actually a very powerful way of retrieving that wide range of data from the collections, from the repositories. But one of the challenges is that this is very difficult to use, and especially remembering all these different data models and all these different data fields, is very difficult to know every single data field of every single collection that we're going to be using, or every single ontology that we're going to use. So what Europeana has done is to integrate their data model, or the wide range of data fields used to describe the collections, within a singular data field. So for instance, anything that is related to people, such as creators, such as DC creator from Dublin Core, or organizations, are being described now as a single data field called who. Everything that is related to dates is integrated within a single data field called when. This way, we can use the API to query in a more accessible way the data from their data model. So I'm going to be using this system called, or this software called Postman, which is just for us to test API calls. So what I have here is basically the Europeana call to retrieve the data in JSON format, and I have my my key for Europeana, and then I begin the query when I'm gonna look for objects from when to 800 to medieval. So as you can see, the word medieval is being used to describe within the data model a range of time. So this way we can combine numerical dates with concepts of dates. So this way I can just make that query and retrieve my data in JSON format. So I can see the actual description of the object. Let me see if I can find concept. So this way, what we find here is that Europeana has a label to describe periods of time. So this way, that's what enables us to use the term medieval to find that particular element or that particular object within the collection. But we can easily change the queries that we can produce. So I can query for who, let's say Picasso. I can send the query, and that way I retrieve a particular collection where the author is actually Picasso. I can say I can say medieval as a concept, and that way I also retrieve a particular range of objects. So I can say what medieval, and what coin? So perhaps coins from medieval times. So this way I have access to that particular object. I can see also, it will give me the location of the object. So this way I have a wide range of data fields that I can use to visualize and to play around by using the API calls. So this way, what I'm able to do is use those different data fields from their API to attach them to the particular Python, and then enable the user to combine those API calls and the booleans to produce their own queries. So what we see here on this tangible interface is basically the Pythons are actually replacing the data fields of the API that are already encompassing a wide range of data fields from different data models, and enables the user to fill up a form where they use the input, their own syntax, to produce a particular query. So that way the user is just focusing on the actual query itself and not trying to figure out which data fields represent what. This of course is facilitated a lot through the API. And that way, by using just JavaScript and different technologies, web technologies, enables the user to produce those queries. But the important thing here is the facilitation of the engagement with the data itself. The user is able to produce a wide range of complex queries, because usually users just produce a query from single keywords, or no more than 2 or even 3 if they're lucky. They're going to be using very short queries to produce their searches. As you can see, also I produce also a navigational tool for them to browse the collection once they're depicted on the interface.